What's H1? What's the high? That's crazy. So how many tail tests will this be? Two tail tests. I like it. This could go up or down, so it could be different from something. So can we use z-scores? What officially can we use here? What's up? Sorry.
Well, there's a T right there.
They're total, yes. But this could easily be Z if I know sigma 1 and sigma 2. Yeah. If I don't know sigma 1 and sigma 2, then it's going to be T. So what's wrong, though? Why can't I actually use anything here until I say something?
We don't know the stuff.
Beautiful. So if I tell you it is normally distributed, so if I tell you that, then what can we use? What do we have to use? Do we know sigma? Do we know the population standard deviation? No, shit. All we got is the stuff from the samples we took. So we only know S1 and S2, so we have to use T. Okay. And yes, it is kind of a big giveaway that my whole focus up here was about a T-score, because I knew we were going to do a T problem, but very easily they could have said that we knew the standard deviations already. So then you would use the Z-score if it was wrong. Alright, so take a minute. We have our new degrees of freedom formula, right? It's going to be N1 plus N2 minus 2. So I get 26 minus 2, I get 24. And we know it's going to be a two-tail test. So it's two-tail. Degrees of freedom is 24. Alpha is 0.05. Can you put all that together and give me a T-score? Can't stop myself from saying something stupid. Give me a T-score. I like that reaction. Alright guys, so alpha is 0.05. It's a two-tail test, so I'm right there in the middle of everything. I want to go down until I hit 24 and then I stop. Wait. So I get 2.064. That's going to be how far enough away to show evidence that they're not the same. So 2.064. So how do I put this together then? How many tail tests again? 2. So this is going to be 2.064, and this is going to be negative 2.064. So if T star greater than 2.064, oh my God, what language? Or T star less than negative 2.064, we can reject the null, support the high. So if it's big enough or small enough, big enough negative, far enough away, we can reject the guy that thinks it's in the middle and support the guy that thinks it's far away. Alright, so now you guys take a minute and see if you can calculate that. The formula is a little disgusting. You got to tell the calculator this is on the top. And you got to make sure that this whole thing is in the square root. is actually true data from, it's probably about 4 semesters ago by now. Alright guys, so here's how you want to be careful about putting this in. So parentheses, 80.46 is x bar 1 minus 76.29. Divide that by the square root. Now I have the newer version of the operating system on there, so my square root symbol just grows. I love that shit. If you have the old one, it opens up parentheses. Don't close it until you put all that stuff in there, or else you're going to be outside the square root. It's not going to do the right thing. User error is the biggest reason why it spits out the wrong number. And then another procedural mistake people make is they forget to square those poor little s dudes. Right? So it'll be, where to go? 14.85 squared divided by 14. Right, that's S1 and N1. Plus 13.68 squared divided by 12. S2 squared over N2. And now it should be ready. Yeah. So from there, right there, from just looking at that, is that very far apart? Is it a full step apart? Are they a full step apart from each other? No, they're like 3/4 of a step apart from each other. It's the same thing as always. Right? This number that we just calculated is the same thing that we calculated before. It's related to like the z-score. It tells me how far apart they are relative to the data. This ain't very far apart at all. Right? Even though, remember, the numbers were 80.5 versus 76.3. I mean, I would think that that was decently far apart, but remember the standard deviations are pretty big. So relative to how far apart the data is anyway, those two numbers are not far apart enough. Because where does that fall on my projection regions? Let me write this down. This is 0.74. So 0.74 is just freaking right there. It's not very far at all. It's not even a full step away. Remember, this middle is going to be that there's no difference. So there is some difference, obviously, but that difference is not big enough to be evidence that the whole populations are different. Maybe. Because they still, even after all this discussion, I'm always going to have some student that says, well, I see the difference. Why do I have to do all this shit? They have to be different enough, because they only came from samples, not the entire population. And these are pretty freaking small samples too, right? That's another reason why it wasn't enough evidence. It's very small samples. So, what can I say right here then? Did we make it? No. So we failed to reject the null. Failed to support the high. And which one was the claim? So I'm going to use this language right there. I'm going to use that language to write my conclusion. So take a minute and try to write the conclusion. Alright, it's going to go like this. Fail. Oh shit. So we have not found sufficient evidence to reject. The claim was the host, so we used this language here. There's no ambiguity, there's no guessing, there's no, oh God, please be this word. Whatever the claim was, you know which language to use. So we failed, we have not found sufficient evidence to reject the claim that what? Female mean grade and male grade, female. Male mean grade are different, or I'm sorry, are the same. So we have not found sufficient evidence to reject the claim that female mean grade and male mean grade are the same. So we can't say they're not the same. So, does that prove that they are the same? No. That's why we never accept the no. Because just because we didn't reject it now doesn't mean some other study later might reject it. We just, at the moment, we don't have enough evidence to say it's to reject it. So I like it. So the wording does make a difference. I personally believe that's plenty for today. I'm going to go home and drink a lot. Down somewhere.
It was not like, I was like really all by myself, and I was just in my room, just like sad, like just depressed. I was mad. I didn't even hit sad. I hit mad.
I think it's a lot of people thought Hillary had it in the bag, and they just didn't go.
What breaks my heart is that we're not as progressive as we thought.
As what?
As like progressive as we thought. We're not as like open as we thought we are. We're very, it's like a shock. You know, I think the bubbles is red house, and it's like, well, but in other states, it's clear that.
What I'm worried about, though, is there's always been this populated subgroup of people that have thankfully felt that they couldn't speak up because they knew that their views weren't socially acceptable. And I'm not saying every Trump supporter is like that, but obviously a huge number of them are. And now they're going to feel fine to be open about their remarkably ignorant views, and that's a huge step backwards.
I literally just like I shed a tear when the results. But this whole election is a shit show of oh no she did this no she did this.
Oh, and then Comey coming out with the cryptic thing about the emails. I mean, who knows? Who knows?